This is 11.6. We're starting, this is day 2. So yesterday we found standard deviation and we found variance. Today what we're going to deal with is actually using the standard deviation now. So yesterday when we found our standard deviation, we found that, or we were told that that was a way of measuring the spread of our data. So if we have a mean of 50 and the standard deviation is 10, then a value x, so that would be a value in your data set, could be within, it would be 40, which is less than or equal to that value in your data set, which is less than or equal to 60. That's within one standard deviation of the mean. So that's how we're going to use the standard deviation. This is giving us a range to go by using the standard deviation, and what it shows is how far away our data is from the mean. So in example 1, it says if the mean is 24 and the standard deviation is 6, what would the range of the data values be that are within 2 standard deviations of the mean? So like up here where it has this is a range. One standard deviation away from the mean, you have to go in both directions. So you go to the left of the mean and to the right. So when we're thinking about this, we're going to take our mean value. So in example 1, it's 24. So we're going to take 24. And if we want to go to the left of that 24, it's going to be a smaller number than 24. So we're going to subtract 6. We're subtracting the standard deviation. So that gives us an 18. Then we also want to find to the right of your mean. So we're going to take 24 and we're going to add 6. And that's going to give us 30. So if we were looking at one standard deviation away from the mean, then our range for one standard deviation we're going to write our range like it appears here, this 40 less than or equal to x less than or equal to 60. That's what the range is going to look like. So we're going to take our smaller number, which is 18, is less than or equal to x, which is less than or equal to 30. So that's for one standard deviation. Again, you have to go on both sides of the mean. That's what one standard deviation means. So if we want to find, because the problem is asking within 2 standard deviations. So now we're going to take our smaller number, which is our 18, and we're going to subtract 6. Again, we're subtracting the standard deviation again. So we're going to get 12. And what these numbers are, they're getting farther and farther away from the mean. Then we're going to take our larger number, which was our 30, and we want to add 6 again. And that'll give us that second deviation to the right. So that gives us 36. So the question asks what the range is for values within 2 standard deviations. So 2 standard deviations. We take our smaller number, is less than or equal to x, is less than or equal to 36. So our range is between 12 and 36. So what that's saying is that x could be any of the data values in our set, but they have to be between 12 and 36. Those are all the values that would be within 2 standard deviations for this problem. So now we're going to kind of put together what we did yesterday and then what we're talking about today. So problem 2, we have a table that displays the number of hurricanes in the Atlantic Ocean from 92 to 2006. And we need to find the mean and the standard deviation. And then we're actually going to use a number line to plot all of our data points and find standard deviations for it. So part A is finding the mean and the standard deviation. So we're going to do what we did yesterday on the calculator. So if we remember, we took our calculator. To input our data, we're going to go new document, which is number 1. We don't care about saving the unsaved data. We're going to go to number 4, add lists and spreadsheet. Hit enter. We should get an Excel looking screen. And now we're going to input all of our data values. Now for this one, our data values are not the years. The years are just telling us how many hurricanes occurred each year. We're interested in the number of hurricanes that occurred. So that's the data that you're going to enter. So we're going to put 4, 4, 3, 11, 10, 3, 10, 8, 8, 9, 4, 7, 9, 14, and 5. And after you put that last data point in, make sure you hit enter. Otherwise your calculation won't come up when we go to do it. So now you want to go, now that you've entered all your data, you want to go to menu. You're going to go down to number 4, which says statistics. We're going to do number 1, stat calculation. And then we're going to do one variable statistics and hit enter. You're going to hit enter to get rid of the one variable statistics that it says num of lists. Just hit enter. This will come up, hit enter again, and then all of your stats will come up on your screen. And what you're looking for once your stats come up is you're looking for your X bar. So it'll have an X with a bar over it. That's your mean. So our mean for this problem is 7.3 if we round. So we have a mean of 7.3. Your standard deviation is down a little bit. It's a sigma followed by an X. For our problem, it's 3.2. So when you do it on the calculator, you need to be able to find where the mean is and where the standard deviation is. Now, for part B, it wants us to create a number line by plotting all of the data values. So all of those data values that we just put in our table to find the mean and the standard deviation, we need to plot all of those. And we need to show the mean in the center of our number line. And then we're going to add and subtract standard deviations in each direction until all of our data points or values are included within a certain number of standard deviations. So the first thing that we're going to want to do is plot our mean, and it wants it in the middle of our number line. So if we put a dot right in the middle, that's 7.3. That's what we found our mean to be. And just a way of seeing it a little clearer, we're going to draw a dotted line across the middle so we know that that's our mean. That's the middle of our data. Now we're just going to kind of label our number line. And yours can look different than mine, but I'm going to order mine by 2s. So I'm going to start at -4, because you always want to start a little bit under where your lowest number is and then go a little bit over where your largest number is. And like I say, yours doesn't have to look like mine, as long as you have all the information. you'll be fine. So I just counted by 2s on my number line. So now what we're going to do is we're going to plot all of our data values that we have. And the way that we're going to do that is we're going to mark them with X's, and we're just going to kind of stack them on top of each other so we can see them. So we've got a 4, so we'll put an X at the 4. Then we've got another 4, so we'll just put an X on top. So we have 2 X's now at 4. We have a 3, so that's in between our 2 and our 4. We've got an 11, that's in between the 10 and the 12. We've got another 3. Oh, I skipped the 10, we've got a 10 too. So then 3, and now we're at this 10. So we've got another 10, then we've got an 8. We've got another 8. We've got a 9. We've got another 4. We've got a 7, so that's just a little bit to the left of our mean. So we'll just put an X kind of next to our mean there. We've got another 9. We've got a 14. And then we have a 5. So those are all of our data values plotted on our number line. So now what we need to do is we need to add and subtract standard deviations in each direction until all of our data values are included. So that's going to be like what we did in example 1. So to find one standard deviation, we're going to take our mean, which was 7.3. We're going to take our 7.3 and we're going to subtract our standard deviation, which is 3.2. And so from our mean, that's going to give us the standard deviation to the left. So when we subtract that, we get 4.1. So we'll plot that. So that's just a little bit past our 4 here. So we'll put a dotted line there. And we'll label it up here as 4.1 so we know where we're at. And then to find the rest of the first standard deviation, we have to find the spot to the right as well. So we're going to take 7.3 plus 3.2. And that'll give us our the rest of the standard deviation on the right-hand side. And that gives us 10.5. So we're at 11 here, so 10.5 is going to be in between the 10 and the 11. So again, drawing dotted line, we're at 10.5 here. So that gives us our first standard deviation. Both of these lines make up the first standard deviation. And if we look at these are 3.2 away from our mean, because that was what we found our standard deviation to be. So they are a distance of 3.2 away from our mean value. So now we need to look at our data. Are all of our data points included within that first standard deviation? They're not. We have data points outside over here and over here. So we need to do a second standard deviation. So we're going to take our new numbers. We're going to take our 4.1 and we're going to subtract 3.2 again. And that'll give us a distance of 3.2 this way. So we get 0.9. And then we're going to take our, so then we can go ahead and graph that. So 1 is right in between the 0 and the 2 here. So we're almost to that point. So we're going to draw our dotted line there. And that's at 0.9. And then we're going to take our 10.5 and add the 3.2. and that gives us 13.7. So then we're going to graph that standard deviation on our line. So that's almost to the 14. So 13.7. So that makes up our second standard deviation. So now we have a total of 2 standard deviations graphed. Now, again, we need to look. Are all of our data points included within those 2 standard deviations? And they're not. We have a point still right here that's just outside of that standard deviation. So now we're going to have to do a third standard deviation. So we're going to take our lower number, our 0.9, and subtract the 3.2. So we're going to get a negative 2.3. So we'll graph that. So that's just a little bit past our 2 here. So that's our negative 2.3. And then we need to find our other side on the right. So we're going to take 13.7 and add 3.2. And that's going to give us 16.9. So then we want to graph that. So that's almost halfway between the 16 and the 18. So that's our 16.9. So now we have a total of 3 standard deviations graphed on our number line. So now are all of our points included within those 3 standard deviations? And they are. We don't have any more data values that are outside of those standard deviations. So letter C asks us, how many standard deviations of the mean do all of the values fall? So within how many standard deviations did all of our values fall? And it took 3 standard deviations to include all of our values. So they fall within 3 standard deviations. So it's very important to remember that when you're talking about where your data values are falling, that a standard deviation is both of these lines in both directions. So to the left and to the right. That is one standard deviation. Then you have a second and a third. So that is one of the key things to remember about standard deviation, is that it's a range. It's not just one single value. So the last 2 pages are homework. The first 2 follow right along with what we just did basically. You're given the mean and the standard deviation, and you're asked to graph it on the number line. And then you also need to tell how many standard deviations it took to include all of the values for the first 2. The third one, you have to find the mean and the standard deviation on your own. You can use the calculator. And then in part B, you need to draw and graph the points and the standard deviations. But for part B, it wants you to tell them how many values fall within that first standard deviation, how many fall within 2 standard deviations, and then how many values fall within 3 standard deviations. So you're going to be analyzing given each standard deviation. And we're done.